Section 9.4 is arithmetic series. I can define arithmetic series and find their sums. Big ideas here are, when two terms and the number of terms in a finite arithmetic sequence are known, the sum of the terms can be found. Finite here just means we know how many, an exact value, versus infinite that goes on forever. A sequence can be defined explicitly by describing its nth term with a formula using n, or recursively by stating its first term and a formula for its nth term using the n-1 term, or the term before it. A series is the indicated sum of the terms of a sequence. So sequences that we've been dealing with the last two sections, now a series is when we add those values together. A finite series has a first term and a last term. It has a beginning and an end. An infinite series continues without end, just like infinity. Okay, there's examples of those on page 587. An arithmetic series is a series whose terms form an arithmetic sequence. When a series has a finite number of terms, we use a formula based on the first and last terms to find the sum. So the take note on page 587 talks about the sum of finite arithmetic series. The sum, S sub n, meaning based on a certain number of terms, of a finite arithmetic series, we add up all the values until we get to the nth term, and that's where we stop, whatever value we're looking for. So arithmetic sequences go on. We can keep adding 4 or subtracting 3 or whatever it happens to be, but a finite series is when we only want the first 10, or we only want the ones between 1 and 100, or however it may be. There is a defined endpoint. So the sum of our series based off that number of terms is going to be the number of terms divided by 2 times the sum, in parentheses there, of our first term and our nth term, which is our last term that we're using. Basically what we're doing here, guys, and it doesn't necessarily look that way based on how it's written, but we are taking the average of the two terms and then multiplying by how many of them we have. If we take our first term and our last term divided by 2, that's our average. And we take that average times how many numbers that we have, our n value. How many times do we have that average? And that gives us our sum. So example 1 here says, finding the sum of a finite arithmetic series. We want to know, what is the sum of the even integers from 2 to 100? So our formula here, we have S sub n equals n divided by 2 times the value of our first term plus the value or the amount of our nth term. Now, we know our first term and our last term, so we can plug those in. But we don't know how many terms we have. Some of you might say, well, if it's even numbers to 100, that's just 50. But for those of you that didn't figure that out, and for problems where it's not as easy to see, we can figure out our n value by using our explicit form for the sequence. So the sequence itself, a of n equals our first term, 2, plus our n-1, and our common difference. We want even integers, so our common difference is 2. The term that we have, the other term we know here, our final term is the 100. So we can solve this for n. Subtract 2. Divide by 2. We get 249. Add 1. So n equals 50. So 50 is our n value. We can go ahead and simplify here. 50 divided by 2 is 25. And 2 plus 100 is 102. When we multiply those, okay, we are going to get 2,550. And that is the sum of the first 50 numbers in the sequence. Same thing here, we want to find the sum. So our formula for the sum, S sub n, equals the average times the number of terms. So n divided by 2 times a sub 1, our first term, plus a sub n, our last term. Here again, we know our values. We know our first term. We know our last term. We just don't know our n value. So right now, this is the information I have. But I don't know how many numbers we're adding up. I have to figure that out. So I'm going to write my explicit formula. A sub n, my final number is 99. Our first term plus n minus 1 times our common difference. And if we look here, every time we add 5, we add 5, we add 5. I'm going to solve, subtract 4, divide by 5, add 1, and I get n equals 20. S sub n equals 10 times 103, which is 1,030. And it's S sub 20. It's our first 20 terms in the sequence add up to 1,030. Example 2 here says a company pays a $10,000 bonus to salespeople at the end of their first 50 weeks if they make 10 sales in their first week and then improve their sale number by 2 every week thereafter. One salesperson qualified for the bonus with the minimum possible number of sales. How many sales did the salesperson make in week 50? And then how many in all the weeks combined? So when we're looking for just a specific value, when we're looking for just week 50, we want the 50th number in the sequence. Okay? When we're looking for in all 50 weeks, that's when we want to use a series and add them up. So in just week 50, we're going to go ahead and use our explicit formula from section 9.2. A sub n, again, equals our first term plus n minus 1 times our common difference. Here, our first week, it says we need 10 sales. The number that we're looking for is week 50. And our common difference is 2 each week. So times 2. 10 plus 49 times 2. 10 plus 98 is going to give us the amount of the 50th term to be 108 sales. Now, we want to know what was the total for all 50 weeks. So, we take S for the first 50 terms, the sum of the first 50 terms is going to be N, which here is 50, over 2 times our first value. We said the first value is 10, and our last value is 108, our 50th value right here. Okay, so again, instead of n, I put in the n that we knew. Now I'm going to go ahead and simplify this. $50 divided by 2 is 25. Add those up and I get 118. 25 times 118 is going to be 2,950 sales. So in the 50th week, 108 sales, and all 50 weeks combined, 2,950 sales. That's all 50 weeks. Go ahead and try this one. The company in example 2 has an alternate bonus plan. It pays a $5,000 bonus if a new salesperson makes 10 sales in the first week and then improves by 1 sale per week each week thereafter. One salesperson qualified for this bonus with the minimum number of sales. How many sales did the salesperson make in week 50 and in all weeks? So when we're looking for the specific value, when we're looking for just week 50, we're looking for that term, which means we're going to use our sequence. A sub n equals our first term plus our common difference times our n minus 1 term. Not the term, sorry, just n minus 1. We want the 50th term. It said still 10 sales the first week. That's where we started at. Week is 50. And our common difference here is just 1 sale per week. So we can go ahead and simplify here. The amount of our 50th week is going to be 10 plus 50 minus 1 is 49 times 1 is just 49. So in the 50th week, there were 59 sales. Now, we need to find, how about in all 50 weeks? So we're going to try and find the sum here. We want to know in all 50 weeks combined. So our sum of a set of numbers is n divided by 2 times our first amount plus our last amount. Here, the amount of terms we're adding is 50. We're adding every week. So n is going to be 50. Our first term again is 10 right here. And the amount of our 50th term is 59. So S of 50, so the sum of the first 50 numbers is going to be 25 times 69, which is going to be 1,725 sales. So in 50 weeks, starting at 10, adding 1 per week gives you 1,725 sales. I'm going to go ahead and stop this video here and continue on the next one.